Hello all, this is Anita. Welcome to the Machine Learning video lecture series. In this lecture, we will understand the Advanced Ensemble Learning Technique, that is bagging, in detail. So let's get started. So as we have discussed, this bagging is one of the Advanced Ensemble Learning Technique. So first is, what is bagging? Bagging is nothing but the bootstrap aggregating is an ensemble method that involves training the multiple model independently on random subset of data and aggregating their predictions through the voting or averaging technique. So it consists of the two steps. The first one is bootstrapping and the second one is the aggregating. So let us look at what is bootstrapping. So it involves resampling the subset of data with replacement from an initial data set. So in other words, we can say that the subset of data are taken from the initial data set. So these subset of data are called as bootstrap data set or simply the bootstrap. So resampled with replacement means an individual data point can be sampled multiple times. So each bootstrap data set is used to train the weak learner. The second method is the aggregating. So here in aggregating, the individual weak learner are trained independently from each other and each learner make the independent predictions. So the result of those predictions are aggregated at the end to get the overall predictions. And the predictions are aggregated using either max voting or the averaging technique. So here we will be using the max voting or the averaging technique for aggregating the predicted results. Now let us look at the how this bagging process done. So the first one is, here you can see we have initial training data set containing n number of instances. So suppose this data set containing n number of instances. After that we create m number of subsets of the data from this training data set, and we take a subset of n sample point from the initial subset. For each subset is taken with replacement here, and this means that the specific data point can be sampled more than once. So for each subset of data, we train the corresponding weak learner independently, and these models are the homogeneous models, meaning that they are having the same type, and after that each model makes the prediction. So here on the fourth step, each model is making the predictions, and then the prediction are aggregated into a single predictions. So for this, either we use the max voting or the averaging is used. So this is how this process of bagging works. So now let us look at the one of the example, the similar example I have considered. Suppose like I want to classify uh, one problem, and that classification is the binary classification, and with the uh, data set D. So here you can see for particular problem statement I have a data set D. That means this data set is having many columns and row. And as I said, ensemble means what? We are combining the multiple model. So similarly here we are creating the multiple model. So this M1, M2, M3 up to Mn. So these are the multiple model. So with respect to this model, what we will do is that for each and every model, we provide some sample of data set. So here you can see D dash of M. So this is a sample of data set I have taken from this D data, and this D data contain the N number of records. So that here you can see that M is less than N. It is always less than N. So similarly for the next model, again I am taking the or resampling the records. Again we pick the D double dash M records, and I am giving it to the M2 model. So similarly I am doing for the all other models. So here basically I am using the row sampling with replacement technique. So here you can see that that d dash m is not equal to d double dash m. So here maybe some of the record may get repeated. So similarly, we are providing the data, subset of data to all the model, and after that the training done. So this model after training done, suppose from my test data set, I am giving the new data and I am trying to predict the results. So this here we have considered it is a binary classification problem. So this the first day model gives me the result as a 1, the second one is giving as a 0, third one giving as a 1. So similarly the model is giving the predictions. So based on the majority voting classifier, here we will be considering the majority vote given by the model. So the output is 1 based on that majority, because here you can see the majority vote is 1, so that's why the output is 1. So here this is a parallel approach. So each model is trained independently, or we can say parallelly. So now you can see this is also called as bootstrap aggregation. So here whatever data set we are having, so we are uh, taken the samples with replacement. So this is called as bootstrapping. And here we are aggregating the predicted results using the voting classifier or the averaging technique. So this is called as a aggregation. So this is how this bagging technique works. Now we will look at the advantages of the bagging technique. So the first advantage is it reduces the overfitting. So it can reduce the chance of an overfit model, resulting in improved model accuracy on the unseen data. The second one is the decreases the model variance. So here multiple model train on different subset of data. So average out their prediction, leading to lower variance than a single model. The third one is improve the stability. So changes in the training data set have the less impact on the bag model. So making overall model is more stable. The next one is the parallelizable computation. So each model in the ensemble can be trained independently and allowing for parallel processing and efficient use of the computational resources. Next one is the good with the noisy data. So the averaging process helps in reducing the noise in the final predictions. Next one is the handles the imbalanced data. So here bagging can help in the scenarios where the data set is imbalanced and improving the performance of the model in such a situations. So last one is it is easy to understand and implement. So the concept behind the bagging is straightforward and can be implemented without complex modifications to the learning algorithm. So these are the advantages of the bagging technique. So now in the next video, we will understand the random forest as one of the bagging technique in detail. Thank you.